Hi, welcome back to our tutorial on application of trigonometry. And just to let you know, the application of Trigo is basically how you use your Tuakaso, your Pythagoras theorem, sine rule, cosine rules in real life scenarios. Okay, so if you look at your screen on the left hand side here, I'm not sure if you can see it clearly, but maybe I can try to zoom in a little bit. And okay, so if you look here, this is quite a real life scenario of situations, and you are required to find the angle of elevation or depression. Okay, so in the first case, the angle of elevation of a lamppost AB from point C on the ground is 23 meters, from its base is 28 degrees, and then you are asked to find the height of the lamppost. Okay, so it's a real life scenario. You are supposed to use trigonometry to solve this situation. Okay, and next one is about plane on the in the air, and then you need to find the angle of depression, a ladder against a wall, and so on. Okay, so I'm just going to go back to our original setting. And okay, so first things first, what you need to remember is that anytime you deal with angle of elevation and depression, you are involving a right angle triangle. Okay, it always involves a right angle triangle. So in the case of the lamppost, in the case of a wall and the ladder, okay, so this vertical structure here, if you see on your triangle, on this triangle, this red part is always 90 degrees with the ground. Okay, is always in 90 degrees. So this vertical structure, let's name it as A, B, and C. So AB can be a lamppost, okay? It can be a tree, it can be a wall, it can be a lighthouse, okay? You will see these examples a lot of time. So it can be anything, and the vertical height, the height is always the vertical height of that structure, okay? So, and just to reiterate, it is always in 90 degrees with the ground, okay? So, how do you find the angle of elevation and depression? In order for you to answer that, you need to know where is the angle of elevation and depression. So let's say you need to find the angle of elevation of A from C. So this with respect to a diagram. Okay, so there is a keyword here, and the keyword is our reference point. The reference point is where they say from. So this is the reference point that we want to know. So you will start measuring from the reference point. So you go to the reference point, which is over here, part C, and find the horizontal, which is this line. BC is our horizontal line. Okay, so from the horizontal line, angle of elevation is going upwards. So here, oh, sorry. Let me go back my explanation. So we identify the reference point, which is C, and then we need to find where. Okay, where is the end point? In this case, angle of elevation of A from C. So we're talking about point A and a point A and point C. Okay. So these are the 2 points involved, point A and point C. So now we go back to our reference point, which is at point C here, and identify the horizontal, which is this blue line, and the angle of elevation is measured upwards from the horizontal to the line connecting A and C. So this is the angle of elevation. Okay, that is our angle of elevation. That is the angle I need to find, basically. So with this, I'm just going to go and explain how to find, or where is the angle of depression. So let's say they ask you to find the angle of depression of C from A. So if you notice carefully, it is now the other way around. Angle of depression of C from A. So we are involving the same 2 points, A and C, but the reference is now different. It's now point A. So we go to point A up here, and then we need to draw the imaginary horizontal. Okay, the imaginary horizontal is here. Okay, and this horizontal together with the horizontal at the bottom, they are the same. Okay, so the blue lines that you see on the screen here, the horizontal blue lines that you see on the screen are the same. Okay, they are in the same direction. Okay, so where is the angle of depression? So we go to point A. It's always measured from the horizontal, but angle of depression is measured downwards. So this is the angle of depression. Okay, so if you recall, I just said that the two blue lines are the same. They are parallel to one another. They are in the same direction. That means this line, okay, this line and this line here are parallel to one another. And because of this line AC connecting those two lines, it means the angle of depression and angle of elevation are the same because they are alternate angles. Okay, angle of elevation is equals to angle of depression are equal because they are alternate. Okay, this is what you learned in Sec 1. Okay, so this is angle. This is the introduction for your angle of elevation and depression, and we'll catch you at the next video. I will show you how to use this situation or how to solve your angle of elevation and depression using the work examples here. Okay, catch you in a bit.